Welcome back. The insertion sort. The insertion sort is a simple sorting algorithm, but again, it is not usually the most efficient. To sort a list with n elements, the insertion sort takes the following steps. Compare the second element with the first element. If the second element is smaller than the first, then the second is inserted before the first. Now compare the third element with the first two. So you see, third element has two comparisons. Insert it appropriately, so on. So the second element has one comparison, third element has two comparisons, fourth element will have three comparisons, so on. Jth step, the jth element is compared with the previous j minus 1 elements and sorted in the correct and inserted into the correct position. So this is a linear search technique is used. So fifth part is the algorithm continues until the last element is placed in the correct position. So what is this linear search? You see, you already have a sorted list of j minus 1 elements. So j is looking for its position in the j minus 1 one at a time. That's what that linear search is, if you remember. So let's look at this example. 8, 9, 7, 5, 3, 2, 1, 2, 4, 1, 6. Okay, so here is the list. The second element compares with the first element. Well, it is bigger, so there is no change. Okay, there is no change because this is bigger than this. Now the third one will compare with this, will compare with this. So you see there is a linear search. So this is already sorted here. So 7 compares with 8. Oh, it is smaller. So it goes first. 8 follows, 9 follows. The rest are as they were. Now 5. 5 compares with the already sorted list here, 7, 8. It starts with the very first. Oh, 5 is smaller than 7. So 5 comes first, then 7, then 8, 9, and then 3, 2, 4, 1, 6. At this point, look at 3. 3 is going to compare with the previous elements. It doesn't have to compare with everyone. It's linear search, so it starts from the first one here. So 3 comes before 5. 3 is done. 2, 4, 1, 6. Now 2. 2 compares in the previous one. 2 comes first. 4, 1, 6. Now 4. 4 compares with 2. Then it compares with 3. And then it compares with 5. And you know 4 will come here. So 2, 2, 3, 4, 5, 7, 8, 9, 1, 6. Now this one looks at the previous list. So 1 is smaller than 2, so it's gone there within the first search. Lastly, 6 looks at 1, compares with 1. 6 is bigger, then compares with 2. 6 is bigger, compares with 3. 6 is bigger, compares with 4. 6 is bigger, compares with 5. 6 is bigger, compares with 7. 6 is smaller, so you know 6 is going to come here. So of course we went through this slowly, but that's how every step will take its time. And now you have a sorted list. So this is the insertion sort. So notice the procedure. Procedure is called insertion sort. You're given a list of n elements, a1 through an, they're real numbers. at least two real numbers. So for j going from 2 to n, so if you remember, we started from the second element onwards. So the second element compares with the first, third element compares with the first two, and so on. So start from the second element and you compare until the last element. Start from second element, go until the last element. Now you are comparing with the first guy. If I is 1, if my ajth element, so if my jth element is bigger than the ai, okay, so for example, I'm looking at this particular step. There you go. This is a nice example. So all of this sorted, say you're looking at 4, right? So start with the first element. If this is bigger than this, then move to the next location. Compare. That's all we are doing. If my ajth element is greater than ai, then update I. That is, move. Now compare with the next one. So this is a while loop. As long as aj is bigger than ai, you keep moving to the right. The moment aj is not greater than ai, that is, it has to be less than ai because my entries are all distinct. Moment I am, so let me call m to be aj. For k going from 0 to j minus, so you're looking at the list beforehand, you shift some of those guys. So if I'm going to insert 4 here, right, I'm going to shift these guys one step over and call ai my chosen m. So you see, I needed to take this jth element, store in a temporary variable m, because my location j is going to change. You see, 4 comes in 3. So whoever was in 3, I don't want to lose him. So they get pushed one position away, one position more. And that's what this is, okay? So this was the insertion sort. Next one, we'll discuss greedy algorithms in our next video.